Welcome to the technical presentation for Conv 141. I'll be talking about Rust and its impact in programming languages. The overall question or topic that I went over in my paper and I will be going over in this presentation is what does it take to develop and maintain a programming language of your own along with the steps required to make it successful. So the main topics that I went over to prove its success or to prove what it takes to become a programming language and what it needs to become are as follows. The origin of the language, and in my case it's Rust, the aspects that Rust adopted from other programming languages, the changes that made Rust as a language stand out from others, its popularity within the community, and its future plans on improvement. So the first body paragraph that I went over in my paper was Rust and its originality. Rust is a relatively new programming language. It's a multi-paradigm language that was developed about 10 years ago. Its creator was Graydon Hoare of Mozilla Research. Sorry if I get the name wrong, but I'm thinking that is Hoare just like Hoare's partitioning. It is spelled the same way, so I'm hoping it is said the same way. This language shares much similarities with C++ during its development, and to kind of reference when C was developed, it was developed during the 1980s. So both of these languages has encountered challenges for their time during development, and more specifically, with when C was being or when C++ was being developed in the 1980s, they had technological difficulties and they had their advancements that they've made so far, and they only had to deal with that to create C++. And yes, those were challenges that are overcome today because we're more into the future, we've advanced in technology, but there are still problems that with C++ didn't have to encounter that we have to encounter now with this new language. So there are both new challenges that they had to encounter when developing their own language. So one of the figures that I've used in my paper was this first figure from IBM, sorry, which is a family tree for Rust and what it took from other programming languages to become what it is now. So as you see on the left side, from 1972, you have ML, which is what it stands for meta language, which is a functional programming language. You have SASL, which is a purely functional programming language. You have C, which is basically coming before C++. And you see in 1985, C++ starting to come around. That's when it was developed. And then 5 years later, Haskell. 6 years later, OCaml, and then about, let's see, 8 years after that, Cyclone. So from all of that to 8 years after Cyclone, Rust was developed using all of that. Rust is considered a C-like language because of its heavy object-oriented um, functions that is taken from C, but it has other abilities as well. Like I said, it's object-oriented like C. It's also imperative, just like C is, and it's functional like Haskell or OCaml. Now, what is the difference between all of these? And these three are different paradigms that a language can fit in. Our first one is object-oriented language. So if a language is object-oriented, it's operated in a way to mimic behaviors of real-world objects. If it is imperative, it operates with the sequential execution of instructions and use of variables for representing memory locations. If it's a functional language, it operates based on the abstract notion of functions and core calculus named lambda calculus. And as a result, since Rust has these three different paradigms to make up the entire language, this can appeal to many different programmers and many different uses that the programmer might see fit using this language. So the second paragraph, or second body paragraph that I dived into my paper was what makes it a standalone language. Yeah, it's hard to come up with an original idea nowadays, and you need to excuse me, reference other people's work, or if you need an idea, it's hard to have an object-oriented language because that is like a set standard you have to fit by, and it kind of every language that is object-oriented kind of run the same way. But what makes it different? What makes it different enough to just not use C or C++? Well, on Rust's website, they have many different, I guess, offers that they try to persuade you that Rust is this great programming language, and they have these little tabs. So for one, excuse me, they have performance. And quote, they say fast and efficient memory with no runtime or garbage collector and can also integrate with other languages. Meaning, since you have no runtime or garbage collector, this means that the user has more flexibility when it comes to memory allocation. They can allocate space just like C++. So in C, this is a lot. This is Rust not holding your hand. If you need certain amount of space, the programmer, if you know the amount of space that you need for a variable or for anything, you can set it, and then you can allocate the space and memory for that, and then free it up later. This is a lot of flexibility, but this is really dangerous in the hands of someone who's not as experienced, because you can get memory leaks and cause your program to not run efficiently. But in the hands of the right programmer, this can be very, very good for time efficiency when it comes to their programs. And for productivity, they claim that they have a user-friendly compiler with useful error messages and great tooling. This is really great because people tend to go for easier to work with compilers that have detailed error messages because they want to know what they did wrong. My third body paragraph has to do with Rust and its popularity. This, for figure 2, I labeled this programming, scripting, and markup languages. This is the same label for the graph. This was taken from Stack Overflow, and it is a survey that was done in the year 2019, and it showed just from the people who have taken the survey on Stack Overflow, businesses and programmers alike. They're like, what is the most popular? What is the most used? It is cut off on this graph, but near the top is JavaScript and other languages. But as you can see towards the bottom of the list, Rust is at a 3.2% on popularity. And that is a pretty low point compared to C, C++, even assembly, and Java is high up there as well, and Python, of course. But it looks like Rust isn't that popular when it comes to businesses and what people want, or not what they want, but what people use. Figure 3, on the other hand, shows something completely different. Figure 3's title was Most Loved, Dreaded, and Wanted Languages. This graph is it contradicts the last graph in terms of, just logical thinking. Like, if it's not that popular, why is it most loved? As you can see, Rust is the number one spot at 83.5% as the most loved programming language. And this is taken, the same survey, same people, and you think, why is that? And then like Python, 73.1%. You go down JavaScript. JavaScript was at the top of the last chart, and now JavaScript's at a 66.8% of most loved in the community. And even though not many people have used Rust, and it's not as common as Java, C++, Python, and other languages that were towards the top of the most popular, the percentage of people that have used Rust absolutely love it. It's a small community that, out of those people, the majority of 83% of, or 83.5% of those people love it. As you see, JavaScript was the most commonly used program language in 2019, yet it's only 66.8% of its users love it, while 3.2 of people that use Rust, 83.5% of them love it. That is a typo on my bad. The fourth body paragraph of my paper had to do with Rust and its plans on future development. this graph, figure 4 named Rust adoption, is a survey taken on the Rust website, their own the programming language's website. And towards the bottom of the page, this is basically what they've asked for as an improve, like they if they like what they wanted to improve in Rust. The font is a little bit blurry, but the top thing says they want better training documentation. And then they want more slash better libraries. Third place, IDE integration, and then for compilation time. So these are basically the top four that they want improved, that the users want improved in the language itself. More specifically, the top problem that the users of Rust have experienced has to do with this training documentation, and several users who were not named in the survey added they want the smoothest learning curve as possible. As a small business, even 4 to 6 weeks to become productive is a lot to ask. Another person said they want more stable libraries, and a third person said they want to improve compile times, as these users who have claimed that they would like these to be improved show in the graph. The developers decided to take a closer look into more mature libraries as a response to this general request. They decided that making more mature libraries was the highest on their list to take a look in and see if they can improve it for the future. To wrap this up, Rust is very successful. Even though it's been around for 10 years and we're at the top of the charts for popularity and the top 5 for most wanted programming languages, it 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 shows that even though it's not as popular, it is popular amongst people who have used it. It is very loved, and what they offer does hold up. They've shown that they are different from their C/C++ relatives, that even though they have used their functionality, they've improved on it. And the user's review really shows that the language offers does hold up and something to look into if you want a great programming language. Okay, this is it. Bye.